Hello and welcome back to VarnVlog. Like I mentioned last time, I think a lot about the use of theory and why it's limited. I talked a lot about alienation and gigification. I went through the fourfold types of alienation we see in Marx's writings in the early philosophical and economic manuscripts, the Paris Manuscripts, as they're often called, from 1844. Today, I'm going to be adding the work of Joseph Tainter in, because this is a model beyond just capitalism, but it's one I think that's really hit us profound today. And we're going to look at it, we're going to apply it and see if it helps us understand a different kind of alienation. We talked about gigification and the way that it actually reduces things through this kind of hyper-Taylorism that lacks the transparency of the early Taylorism. Today, we're looking at hyper-specialization as a social cost and how that in and of itself is alienating. Now, sitting at this intersection of alienation, technological specialization, and atomization, we can use Joseph Tainter's particular ecological framework that applies diminishing marginal returns on complexity in terms of investment in energy and labor, not just in money. And that's actually really important. And this reveals a structural trap that we have to deal with. The mechanisms of modern systems used to solve marginal problems end up isolating human subjects while exponentially inflating the metabolic and administrative cost of keeping society functioning at the same level. It is a wed queen's game, to use a metaphor from Lewis Carroll. The Red Queen has you run faster and faster and faster to stay exactly in the same place. If this feels like you've lived through this in the post-war world, it's because you probably have. But Tainter wrote about this in the 1980s and in the 1970s too, and he continued writing and speaking about it till very recently. And I think I saw a podcast with him from last year. Anyway. Hyper-specialization as both alienation and as epistemic siloing. And classical political economy and its Marxist offshoot, and its development in critical theory, which is also a Marxist offshoot. The division of labor begins as an efficiency gain, but rapidly devolves into alienation. Technical systems complexify, as in you need more and more specialized tasks to be done, where the worker practitioner is separated not just from the product and the labor process, as we talked about with Marx, but from the cognitive grasp of the total apparatus. So you cannot perceive the totality of production. And this actually, in addition to being something that Tainter talks about, you see it implied in Georgi or George Lukash's ideas around reification. I'll come back to that, maybe. Hyper-specialization narrows the scope of human activity to extremely micro domains, optimizing ad check latency algorithms or engineering a specific ceramic coating for a termite blade, or growing organelles for some weird biological computer in Japan. I mean, like, there's all kinds of things that you need more and more knowledge to do. It both takes a lot of your own metabolic processes using less and less knowledge of the general world, and also specializes your knowledge and alienates you from other people. You will notice often once you hit a base level of education, there is increasing social alienation from it, as less and less people understand you and the way you talk. Even though you gather social and intellectual capital from that, it is still alienating as it moves you from more and more people, and you may not necessarily have the money and thus power to compensate for that. Because hyperspecialists require idiosyncratic vocabularies, which we often call jargon, very particular methodologies, technical interfaces, horizontal communication across disciplines often breaks down. We see this from the organization of the academy to the spread of specialized workforces in all kinds of things. Thus, society ceases to share a coherent epistemic horizon in its own social reproduction, which is a big fancy way of saying we don't understand how we make the world anymore. And we barely understand how we make ourselves other than, dating and sex. And that starts breaking down people's sense of social being. Hyper-Specialization does not merely fragment the workplace, though. It restructures social life into more radically atomized institutions. And this is where the epistemic siloing of knowledge, where you have very specialized knowledge and less general knowledge, and that specialized knowledge, even though it's not as efficient in terms of cost, Tainter talks a lot about this. Early education in terms of cost spent, it gives way more benefits than higher education, but higher education is usually more expensive, both to society and to the individual. This is a lot of why I actually talk about things like the DSA's focus on free higher education as weird when not paired with more clear visions of what an effective lower level and base education would be. If you're all coming barely literate at 21, I don't know how much 4 more years of school is going to actually help you. But anyway, hyper-specialization removes direct interdependence too, because you need institutions to mediate people who are so specialized. In less specialized systems, socially interdependence is immediate and negotiated within communities, which often, and numbers which you can conceive. Few hundred. And hyper-technological regimes, dependencies are mediated through abstract social technical stacks, supply chains, digital platforms, regulatory apparatuses, legislative apparatuses, etc. You are removed from the people making the decisions, and you have less input into them. If only that input is, the ability to threaten to kill the person making the rules. I mean, like, seriously, I'm being that direct here. Individuals interact as functional units rather than integrated social beings, but humans are social, and thus this creates a big problem. Because individuals depend entirely on techniques for basic survival, food, linguistics, energy, and communications, but have increasingly direct agency over those systems and little ability to understand those systems to reproduce them, they experience radical subjective powerlessness alongside objective isolation. It's a bummer, but it's true. If you don't know how the system works, you don't know how to remake the system. We talked about this leading to kloogs in the past. Kloogs are collections of things that no one completely understands how they function, etc., etc., etc. Algorithms thus replace collective institutions, routing out individuals into personalized informational silos that mirror the hyper-specializing of the economy and eroding social factors required for collective action. But if we talk about this just in terms of algorithms and technology, it misses the point, because Tainter points out this is true for like Bronze Age technology too. It's not just a digital age thing. And the collapse of complex societies, which came out in 1988, in which I'm going to be teaching a seminar on with the books of Eric Klein on the Bronze Age collapse. Joseph Tainter argues that human societies solve emergent problems by adding layers of complexity. They create new specialized roles, new bureaucratic apparatuses, new technical subsystems, new military expansion, etc., etc., etc. A problem emerges, they add a specialized layer, and they get high initial returns on creating that specialized layer over time. Early industrialization leads to very high GDP outputs. The Roman conquest, according to Tainter in chapter 5 of the Collapse of Complex Societies, was almost free money printing, or free metabolic value printing, because money's not relevant here yet at first, but it declines very quickly. One, you have escalating maintenance costs for a system that is already built. It is not just that you have to keep building, you also have to maintain the prior system, and that has cost. And it requires knowledge, which you have to make and keep. Often easier to invent things and to make sure you know how to fix things 200 years later. 2, this eats into returns on investment. And I don't mean investment in money terms. I also mean it in caloric terms or in labor terms. 3, this leads to increased vulnerability, increased expensive overhead, and then collapse. Early complexity yields high payoffs in this model by Tainter. And we see this in industrialization. Initial investments in basic specialization, metallurgy, sanitation, elementary engineering, basic machinery produces massive leaps in both system capacity and surplus. These seem to even function maybe along the lines of Kondratev raves, which I might do a whole series on too after I go back to Plato for a little while. We'll come back to that. I have a couple other things to get to before that. Once low-hanging fruit problems are solved, though, subsequent problems require increasingly expensive and esoteric or exotic specialization. Spending billions to train PhD subspecialists to build particle accelerationists, or having to find the specific rare minerals deep in the earth to build billion-dollar semiconductors to secure efficiency gains, are having to build increasingly complex machinery to break down more and more kinds of crude oil and get more oil out of places you couldn't get them in the past, like tar sands, are more and more expensive. A hyper-specialist cannot coordinate spontaneously. Excuse me. They require vast, non-productive layers of management, compliance, legal frameworks, and digital interfaces to simply broker interactions between isolated specialists, because they often do not have the interactions amongst themselves to explain their work to each other. And most of their brain power is going into the maintenance of that specialization. And so increasingly, they offload their otherwise impressive brain work to other things. This leads to like the somewhat justified stereotype of the specialist who doesn't know shit about anything else. I've encountered it a lot in my stays in universities. Some people say it might be true of me. I think that's not true. I read a lot of different things, but whatever. And you see this in the way, like today, for example, if you're not a hyper specialist, you're a lot less employable than you were in the past. However, it also means that there's a lot less general knowledge, and hyper specialists have a hard time like being promoted and whatnot. And they often do get promoted because you eventually get out of their skill range of specialization. When you see this alienation that we talked about in the beginning, and we see the atomization coming from epistemic siloing and specialization, gigification, all the things we've talked about, then we add in the Tainter and dynamics, they produce distinct systemic crises. 1, exponential coordination costs with shrinking social capital. That's not obvious, so I'll explain what it means. As atomization dissolves organic trust because people don't interact with each other enough and share communal norms for the same reason, the system must substitute formal, technical, and legalistic complexity to enforce social cohesion. And it's almost necessarily going to become more and more invasive and authoritarian. This dramatically increases the societal overhead while delivering zero net improvements to human well-being, meaning that you need to spend more on policing, military, all these AI things and whatever to control the population to keep things going, which alienates the population because, you know, you are treating them as corralled animals, basically. And then while doing so, you are actually delivering no net improvements to the social well-being, and the cost to you and to society as a whole increases the more and more you have to do this. Look at how much money we're pouring into these AI systems. Look at how much energy we're pouring these AI systems. And it's not just for production. It's also about surveillance. Why? Think about it. Tainter's model explains it. Tie this back into Marx's models of alienation, and you see why you feel so alone. It's not the only reason you feel alone. We shouldn't reduce all loneliness to these things. You could still be lonely for all kinds of social reasons, biochemical reasons, whatever. But this is why this is a general pervasive social problem and not just an individual pathology. A massive portion of social surplus is consumed poorly by the connective tissue required to keep atomized, hyper-specialized subsystems working together. Highly specialized workers must spend increasing portions of their cognitive energy navigating bureaucracy, software tooling, and compliance protocols, rather than solving material problems. Thus, there's less original and new research happening. Because analyzed individuals lack generalized skills and hyper-specialists only know their micro slice of their particular machines or technical needs, the entire social order loses adaptive resilience. You have glass floors pop up for the incompetent, many of whom are still way more competent than also de-skilled gigafied other workers who've also had their skills reduced through the hyper-specialization of gigafied work and this hyper-taylorized management that it involves. If the external shock, resource complaint, supply shock, supply chain break, a disease, whatever stresses the system, they cannot simply step down its complexity smoothly. They can't just start roping it back. The atomized ports cannot self-organize without the overarching technological apparatus, and the overarching technological apparatus is becoming more and more metabolically expensive. And by here, I mean it just takes more energy. Thus, hyper-specialization attempts to engineer around the systemic limits, generating even more complex subdisciplines and more complex kloogs in general society. By kloogs, I just remind you that's all these things that we fix by technical patches that don't redo the system. So all of a sudden you have this system that has 85 peripheral things attached to it that are going all over everywhere, and no one knows how to engineer it because it's too complicated, and you didn't build it as a single or total system. It isolates the individual, dissolves collective cohesion and social identity, and consumes most of the surplus required to sustain social agriculture, and cannibalizes itself. You see more and more areas being devoted to this. If it's in the Roman Empire, it's the high taxation, manorial fiefdoms, etc. If it's today, it's, everything is more expensive and you get less and less for it, and you have profound enshittification, to use a core doctoro term. But you see, if you'd read Joseph Tainter, you would have known enshittification actually is a problem of complex societies as much as it is capitalism. Tainter thus provides us a striking, precise analytical framework for understanding the structural crises that are hitting us today. In software engineering and in corporate institution, complexity is often treated as an asset. It is a sign of sophistication or the ability to scale, particularly if it is centralized. However, complexity actually reduces the benefits of centralization. Centralization is supposed to, and in 19th century understanding of physics, and you see this in Marx too, it's supposed to make all this stuff more efficient because you're not losing stuff to overcomplicated pipelines. But the more you see this overcomplication can occur in a centralized system, then you start to wonder if the issue can be fixed just by centralization. So if we let's just apply this model to software ecosystems, and how institutions that build them have entered a phase of diminishing returns on problem solving, we see an issue. And we also see how we're getting less and less gains in AI, just to make it already quicker. The initial gains in AI were super impressive very quickly in the first 3 years. We're already seeing that slow down. The gains are still impressive, but the energy costs that go into them are exponentially, and maybe more than exponentially, growing. And you have all kinds of problems coming from that. So let's just take Tainter's ideas here and break them down into his 4 key theses. 1, human societies, or any human system, are problem-solving organizations. Problem solving is inherently involved by adding structural complexity, specialization, layers, control mechanisms, if only in more and more advanced social and mechanical technology. Social technology is how you arrange things, like you arrange people. Investments in social technical complexity reach a point of diminishing returns some point in any given system. You can also see this when GDP stalls out. You don't have massive GDP growth like you did in early industrialization or whatever. Continued investment leads to escalating maintenance cost, increased brittleness if it's a centralized system, and eventually vulnerabilities to systemic collapse or force simplification, which is a form of systemic collapse. Early computer sciences solved problems with high marginal returns, moving from machine code to assembly, from assembly to structured high-level languages. You look at Unix primitives, or the move from BASIC to, Java, or from Java to, Python. These abstractions dramatically multiply developer productivity with relatively low maintenance overhead. Modern software, however, exists deep on a flat end of the Tainter curve, and I think it's pretty clear that that's the case, which is why they moved on to AI. To deliver basic user-facing features like rendering a form or processing a payment, modern development environments routinely stack dozens of leaky abstractions on top of each other. Rather than modular systems distributed by Kubernetes clusters, or service meshes, or container runtimes, or API gateways, something I actually know a little bit about, are distributed chasing, you get more and more systems that you have to deal with that interact with each other, and this creates more and more complex problems. A modern front-end application can even put thousands of transitive dependencies, bundlers, transpilers, CSS preprocessors, and state machines just to render static text and dynamic buttons working. Developers spend the majority of their mental energy navigating configuration files, environment parity, dependency security alerts, and build pipelines rather than implementing any clear domain logic. And this actually is diminutive cognitive load for both the machine and the person making the machines. Massive computational resources and millions of lines of code are consumed to replicate the capabilities that 1990s desktop applications executed instantly with a single megabyte of memory. You see this in things like Wirth's law. Software gets slower faster than hardware gets faster. This leads to sunk cost traps, kloogs, and atrophy. Tainter, and correctly, I think, emphasizes that system complexity becomes its own problem, and as systems complexify, the cost of simplification, or simplifying the systems, becomes more prohibitive itself, because you have to get rid of more and more of the complex system. And it's not just you're losing the dead labor that went into the complex system, you're also having to spend the labor to get rid of it, which is costly. Institutions thus patch existing complexity by adding more immediate transition layers, and this leads to the kloogs that I talk about, but it leads to a lot of things. Let's go back to this. One, you get institutional amnesia and the whole black box effect. You see this from political organizing to businesses. Global financial and airline systems often run on legacy COBOL, or mainframe infrastructure designed in the mid-20th century even. Their systems' inner workings are no longer fully understood by the current staff due to retirement, turnover, and undocumented emergent behaviors, aka they're klooed together and no one can retro-engineer the kloog. Instead of modernizing or simplifying the core, institutions build REST or graphic QL wrappers on top of the legacy mainframes. I used to work for a job, and this was a long time ago. This was actually in the early aughts, that we were running Windows-like wrappers on Linux core programming, mainframe programming that were made in the 1970s, but that we were running multiple wrappers over it so we didn't have to change it. In schooling, I often see SMSs, which are and LMSs, which are learning management systems, and SMSs, which are like school management systems, that have been patched up for 20, 30 years. And when you go to reboot them, you have to just rip everything out, and you're basically starting from scratch. But there's legacy systems that are built on it. You have to maintain these things for legal compliance. So booting things over becomes a massive thing to do, and it requires whole teams, massive amounts of investment, and lots of sunk cost. It also creates bunches of places for cascading system failure. A bug in the edge of middleware can actually trigger any kind of cascading failures throughout a legacy core. And it requires crisis teams to undo the whole thing, who don't necessarily understand how these machines were built and how they're klooed on. They have an over complex machine. You can also see this in institutional bloat. Conway's law comes into play here, and we can add it to Tainter. Conway's law dictates that organizations design systems that mirror their own communication structures. When combined with Tainter's diminishing return, this creates what you might say is an isomorphic spiral between bloated software stacks and bloated institutional hierarchies. This leads to too much management. As the size of the team grows, the line of communications grow quadratically. There's actually an equation for this, which means that you need more and more management to do fewer and fewer things. This is also why cost disease and administrative bloat is almost inevitable. It is not just bureaucracy protecting itself, although that is real and it is also happening. It is also that you need more and more people who are hyper specialized, who don't know how to do it, people who are not specialized in the same thing to do it. Thus, you see this in schools first and in other high level things like healthcare. But this goes everywhere and it eats up all your marginal returns. So to manage communication, you need expensive hires like Scrum managers. My brother does this. I know what it does. You need product managers, you need technical managers, you need platform leads, you need compliance auditors, et cetera, et cetera, et cetera. And that's in a private sector software development. You start looking at what this requires for like legal compliance, all this at a school or anything that interfaces with an overly complicated state. And oh my God, you got problems. You know, I've been staking the software terms here because I'm actually trying to apply this to something I don't normally apply here. I normally talk about things that I do, but I know a little bit about software development because I have people who do it in my family. So it's something I think a lot about, and we see this there. If we look at Tainter's model, societies running on diminishing returns become extremely vulnerable to cascading failure and forced simplification, which he actually calls collapse, because they depleted their surplus energy reserves and have no reserves to absorb the shocks. See this in all kinds of ways. And tech industry, we've seen this in a lot of ways prior to AI, and the dynamic manifests in three distinct ways. One is the Big Bang re-regs, or micro collapses. A team reaches a terminal tech debt problem where introducing a new feature takes months instead of days. They attempt to abandon the code base and build a version 2, only to discover the new architecture will eventually reintroduce the same complexity under a new fashionable tooling over time. 3, you have cascading supply chain failures that happen a lot in modern software. Modern software's extreme interdependence means a single point of failure and a trivial undermanaged subdependency can compromise a global system. Think about what happens when you don't update your BIOS on your PC. Think about the left pad management, our Logic 4 vulnerability, or the 2024 CloudStrike outage. You can think of outage. You can think over and over and over again about how this is happening. I know those of you who normally listen to me are surprised I'm talking so much about tech, but continue with me here. When capital is cheap, the zero interest rate regimes, organizations can easily afford to subsidize immense structural bloat. Cough, cough. But when the macroeconomic conditions tighten, our technical debt overwhelms the bottom line, institutions are forced to painful, chaotic reduction, slashing entire platform layers, laying off middle coordination tiers, firing all kinds of people who work there, and then mandating stack consolidation. Tainter reveals that modern tech stacks and engineering organizations are not failing because they lack the tools or talent, although they may like both for reasons of specialization, ironically, itself. They are also failing because they continue to use one strategy that escalates fragility, treating complexity as a solution to problems created by complexity, often meaning that you engineer a system that you cannot retro-engineer and thus recreate. We're going to end here today because I think I've made the sense how specialization becomes a form of atomization and alienation. Now, I've talked about these specializations in terms of software development. I've talked about it in terms of education a little bit, but it has an effect on general social well-being. It's harder and harder to find people who can actually be generalist thinkers. I've often said that that's been left primarily today to journalists in the military, and even that's depleting because they come from highly privileged classes and are actually siloed from a lot of the general population, and thus are often blindsided by obvious things, or they become street tweet stenographers, as I like to call them back in the day, or government propaganda agents, even though they're private and they don't have to be. But I want to talk about more of this in terms of systemics and way you can fight against this over specialization, because it's going to be important for dealing with atomization and organization in the future, if there's going to be a future. And lastly, eventually this will take us to the problem of vision, a big problem. And I'm going to do a whole episode on what I mean by that. But we'll come back. Anyway, like and subscribe, hit the bell. You can find more behind the Patreon. Go to www.varnvlog. There's all kinds of things in the show notes. I hope that you enjoy this. I'm gonna also put a working bibliography in the show notes so you guys can look this stuff up. Don't trust my work, particularly when I'm dealing with stuff like software development, which is something I know a little bit about. I have, my partner does that now, but it's not something I'm a specialist on. So feel free to correct me if I misunderstood anything, but I'm pretty sure I understand the way complexity dynamics work in both the architecture of software and the architecture of software businesses, aka the way we move people. But we'll come back to this in very broad ways and maybe move past the way it affects individuals and to the way it affects systems.